Yeah, everyone. So we're gonna do number of operations to make network connect. Now this, by the way, is my it's just a raw questions that I'm gonna solve. I do not know what this is. I've never seen this question, so I'm just gonna go over how I think. Um, this is probably a bad way to do it, but I'm out here making content to be one, accountable. So if you're here to actually learn something, no, you shouldn't. There are probably better YouTubers out there, like Neat Code, Striver, and other much better YouTubers. You should definitely check them out. And this is just my way to, you know, document what I'm doing. So I would highly suggest not to waste time at all. Yeah, if you just want to see or just think what this is, you're more than welcome. Right, coming to this. So this is number of operations to make network connected. Okay, so there's a medium. Now there are n computers numbered from 0 to n minus 1. Okay, 0 to n minus 1, right, connected by ethernet cable connections. Okay, forming a network where connections I is nothing but a of I b I represents the connection between computer network a and bi. Any computer can reach any other computer directly or indirectly through the network. I mean, it's very very obviously it's a graph question. I mean, you can see the picture. You can even if you if there was no picture involved, right? You'd have done AI and then BI, and it says there's a connection between AI and BI. Uh, it's a and I mean this is the most giveaway part. This is a graph question. Now, because an initial computer network connections, you can extract cables between two directly connected computers and place them between any pair of disconnected computers to make them directly connected. Right. Okay, I see. Now return the minimum number of times you need to do this in order to make all. Okay, so there's minimum number of times you need to do this to make all the computers connected. To make all the computers connected. If not possible, return minus 1. Okay. So this is asking minimum number of times, right? So you have to do min of whatever you're doing, right? Where this resolves the entire, makes all computer connected, right? Now, if you were to see over here, there is 0, 1, 2, and 3. Well, you can either put this up over here, and that is your answer, which is right over here. So let's see how this is built. There is computer 0 to 1, which is like this. Then there is 0 to 2, which is like this, and there's 1 to 2, right? But the n over here is 4, so that means your left out computer is 3. Okay, now what do you do to connect that? Right, we need every single one of them reachable, right? So um yeah, like we can probably put the 3 over here, and then you can do 1. It could have been 3 0, right? um it could have been 1 0 2 0. There are multiple ways to do it, right? So we did this and the output is 1. And what are you exactly doing? You can extract certain and place them in any pair of discrete, make them directly connected. So essentially there's components of graph involved, right? um, Let's see the next example to get even more clarity. So this is 0 to 1, 0 to 2, 0 to 3, 1 to 2, and 1 to 3, and n is 6. There is 4 and then 5. Remember, it's n minus 1. Like, if you look at it, n minus 1. Alright. Now, how do you connect these two? Right, you have to basically break one of this connection and make sure that nothing else gets disconnected. So you break this and you make it this. Okay, that's nice. Now you see there's another connection over here, so you can break this and make it this. So you have your 0 1 4, 0 2 5, and 0 3, right? 0 1 4, 0 2. Okay, I mean, could have been 3, could have been whatever. So at max you need 2 connections to break it. So if you really think about it, I don't think this is a graph question in my point of view, because it just seems like a permutation and combination for me. Now, to be honest, I don't even remember this topic anymore. So let's try to raw dog it. Let's see what happens in the end. I'm gonna give myself 5 minutes. So let's go. Right. So let's see. N is equal to 6 over here. Let's again put up till 5. So it'll be 0 1 2 3 4 and 5. Right. Here 0 to 1. Here 0 to 2. Here 0 to 3. And you have 1 to 2. Okay, right? So you can essentially disconnect this and put this, right? Now you still won't have enough cables to break it. So one thing is for sure, that you need 1 2 3. So you have 3 over here, one more and one more. You need a minimum of n cables to make it work, right? Minimum of n to keep everything connected. um, right, and so let's try to create a hypothesis from this, because n is equal to 6 and we had 1 2 3 4 5, right? When n was 6 and cables were 5, you could have done with just 2 cables. I mean, that basically means n is 5 and c is 5, right? So basically number of components अब तो उसमें से disconnect in that disconnect components there was 2, so 2 here. Let's put the same theory here. N is equal to 3, right? Cable is 3 and this component is 1, so you need only 1. I don't think this really establishes any pattern, so let's create a hypothesis, right? A clear hypothesis to help us out. Now I'm not sure if it will be correct or not, but we can give it a try anyways. Okay, so n minus 1, right? So C is the cable count. Cable count should be greater than or equal. So cable count should be from n minus 1 to whatever is required. Like we'll put that as so there'll be 1 2 3 4 so you have n minus 1 into n minus 2. Okay, so let's see if this holds true. If there are three components rather, right? So there could be one, there could be this, there could be this. This is done, this is done. So in total n minus 1 is minimum, that is 3. This could go here, n minus 1 3, and you can have a maximum of 6, so that's 3 into 2. Yeah, okay, so this is correct. Now let's see. So one condition, so the base condition is if c is less than or c is less than n minus 1, return minus 1, right? Now let's say let's assume we get disconnected components, right? Okay, so like I said, n is 4. Okay, so you'll have 1 2 3 and 4 as a whole. Exactly, we need, if we need 4, we need at least 3 cables, and we can have at max of 6 cables. Oh shoot. Next one down the line, yeah. So that would be 1 2 then 3 and then 4, right, and 5 6. Yep, 6 it is. So this is a disconnected component. I will make it so you need c minus 1 to connect, and we have to connect c minus 1. Disconnected component was 1, total n was 4. Connections, total connections were how much? 3 as a whole. Yeah, now you have a disconnected component, connections of 3, where n is 4, so you have your minimum connections are n minus 1, that is nothing but 3, right? Okay, I think okay, so I don't think I'm correct in any forms of fashion. Let's retry. Let's regroup our thoughts and see, um, you know, what we can do other than this.